Okay, now we have completed the two parts of the lab. The first we looked into the pressure loss variations against the flow, and we obtained the measurements to analyze or visualize the situation with varying flow on the pressure loss. And the second case, we kept the pipe surface temperature at a constant level, and we varied the flow to calculate heat transfer coefficient under different the flow conditions. Now we are at the third situation where we are going to calculate the heat transfer coefficient when the pipes are not inside the sand bed, which are above the sand bed, and we calculate the heat transfer coefficient between pipe and the air, and then we compare that value with the heat transfer coefficient between pipe and the sand, which we have calculated previously, and see how the comparison looks like. So now I am going to take the heater out of the sand bed. So I can do it very easily by unscrewing these two screws here and pulling the heater up. So now we can see the heating element is above the sand bed. So still I have to maintain the same surface temperature as I did in the previous setup. That is 190 on the pipe surface. And also I take the thermocouple number 2 above the sand bed, and then I need to measure the air temperature closer to the heater. So with this under this setup, following the instructions given in the table number 3, so I maintain the two different flow levels for the fluidization, and then I maintain the stabilization situation where the surface temperature is 190, and when it is at the stable condition, I take again the voltage, the current temperatures, as well as bed temperature and element temperature, which is already 190, and by using this data I can calculate the heat transfer coefficient between the pipe and the sand, and then I can compare this heat transfer coefficient which I calculate now for the pipe and air to the heat transfer coefficient I calculated between the pipe and the sand. So we will see these results, and we will conclude, we will discuss about the results later on. The last set of measurements, which is the setup number 4, is related to the table you have, the last table you have in the handout. And there what we are going to do is we are going to maintain the same fluidization flow through the reactor and keeping and changing the surface temperature at different points. So in previous cases we maintained the surface temperature always 190, and in this case we put the pipe inside the sand bed, and we vary the pipe surface temperature and keeping the same fluidization flow, and then we will see whether is there any influence on the pipe surface temperature to the heat transfer coefficient.